we've got some definitions to talk about real quick before we dive into some more examples.
It's always good to have a definition or two.
Yeah, when we see absolute value bars around, we tend to call complex numbers Z for whatever reason. And when you see absolute value bars, that's called the modulus of a complex number.
It's a really fancy word for distance.
Yeah, because we're saying basically if we plot this point in the complex plane, a plus bi, then we're finding that distance from 0 to that point, kind of like a radius, right? Or kind of like a hypotenuse.
Right.
We've been doing this situation like the entire chapter, just with vectors, with polar coordinates,
the whole
and equations.
time. That this should not be a new deal. And with vectors, we recognized length the exact same way with the absolute value bars.
Right.
So this is not even new notation.
Yeah. So that's just what we're saying here. And look, we've got this picture. Even we've got the real axis, imaginary axis. Here's some point a plus bi, and r right here. That's what the modulus is. It's the length of that line to get out to the point.
Right.
So that's our first definition we want to look at. And now we want to look at the definition for trigonometric form of a complex number.
Which can be super handy, actually, as it turns out.
There's some things that you can do with it that you can't do as easily if you have a complex number.
Right.
So the trigonometric form of a complex number is r times cosine theta plus I sine theta. And if you look back at the picture that was just up, it should kind of make sense. And also with what we've done with vectors and things, that the cosine theta, the r cosine theta, that's your x value.
Every single time it's your x value. And it has been since we started talking about trig.
Yes, and r sine theta, that's your y. But our y values in the complex plane have an I. So that's why this I is right here and only right there.
Right.
Okay, because this is giving, the r cosine theta gives us our real part, the r sine theta gives us our imaginary part.
Right.
And these relationships here, like you just said.
What'd you mark out modulus for?
I didn't mean to.
Why
I
did
just
you do
got
that?
carried away. Sorry. These are all very familiar. This is what we've been doing. And so to figure out what this theta is, just like we've been doing, we have to do inverse tangent.
And that's usually the best way to go because you will know A and B.
Yeah.
There's other ways to find it, but usually if you do that arctan, that's the ideal way.
Yeah. And so they call theta the argument of z. That's, I mean, we don't necessarily say that a whole lot.
Why wouldn't you say that?
I mean, I don't think.
Why are you arguing with me?
Never mind. But here's the deal. We're gonna find some trigonometric forms of complex numbers.
Let's do it.
And so 2 plus 2i, we can easily figure out what the modulus of that is, right? 2 squared
Square
plus
root
2
of
squared.
4 plus 4. Square root of 8, 2 square roots of 2.
Right.
Or square root of 8 would be acceptable.
Yeah.
We're not grading reducing radicals with this particular item.
Right. So then the tricky part may be to find theta. And what's important is that whether you draw it out or whether you're just thinking, you need to know what quadrant 2 plus 2i is in.
Yeah, we've got to get the right theta. And if you don't know the right quadrant, you won't get the right theta.
Right. Since this is in the first quadrant, our calculator, if we use our calculator, we actually don't have to on this one.
Nope, not on this one.
But if we use our calculator, it will actually tell us the correct angle because we're in the first quadrant. Any other quadrant, we have to do a little bit more work.
That's correct.
And one way, if you're looking at this, and we just said you don't necessarily have to use your calculator, if you don't recognize that, when you're doing inverse tangent, if you put it in degree mode, even if we may want this in radians, right? If you just test it out in degree mode, and this should come back and tell you, hey, dude, that's 45 degrees.
45, yep.
Hey, that was on our unit circle. And if you think about it, 2 over 2 cancels out and gives you 1, which is 45 degrees.
What angle gives you a tangent of 1?
Right. And so 45 degrees in radians is pi over 4. We'd really rather have radians. So let's just set this up. Looking at z equals that formula up above. R, which is 2 square roots of 2 or square root of 8. And then you put cosine of pi over 4 plus I sine pi over 4. This is the trigonometric form. And all it does is it tells us the radius and angle instead of telling us like an x and a y.
Right.
Okay? It's no big deal.
So
hey, Mr. Bowler.
Dip down in, Mr. Bowler, and you can be in. Say hi to the children.
Yeah.
Here, we'll pause it real quick.
No. Oh.